Okay, just before we start, can I please get confirmation that you guys can hear me? Okay, cool, perfect, thank you. Okay, assalamu alaikum and good morning, guys. Welcome back to grade 12 maths by Inspire Teens. In today's lesson, we're going to be continuing with functions, right? I think last time we ended on intersection of graphs, so we're going to continue there, and we're going to try to get to interval notations and then do some questions as well. Okay, functions is taking quite a while, but yeah, hopefully you guys are understanding as we go along. Please remember, if you guys have any questions, feel free to leave them in the chat, the Q&A or the YouTube chat. Okay, cool. Ramadan Mubarak, by the way, to those who are fasting. Okay. Oh yeah, and good commitment. Well done for those of you who are here on a Saturday morning while fasting at 8 a.m. Okay, so let us start. So just to recap the last few things that we did last week, we went through vertical distance. Okay, we spoke about vertical distance. Then, 1 second. Okay, we spoke about vertical distance, and we also spoke about horizontal distance. So vertical distance, the way we determine vertical distance is we take the top y value and subtract the bottom y value. Okay, so in certain cases, we're calculating the distance between two graphs, and in that case, what we do is we say the top graph, meaning the equation. Remember, the y of a graph is basically f of x, right? Y is basically f of x. So the top graph, this is like saying f of x minus g of x. Okay. Then we talk about horizontal distance. Okay, so we know what a horizontal line is. We say x right minus x left. If you remember, the first thing we discussed in functions is the equation of a horizontal line. And we also said that on a horizontal line, the y value remains the same. So on a horizontal line, that is why, because the y value remains the same, okay, we can just say x right minus x left. For these type of distances, we're not using the analytical geometry formula that is square root x1 plus x2 squared. We are not using those formulas simply because, again, it's a vertical distance. So remember, on a vertical line, the x coordinates remain the same. So since the x coordinates remain the same, when we subtract them, we're going to get 0. So we might as well, we can actually just utilize the y values. When we talk about vertical distance, we can utilize the x values when we talk about horizontal distance. Then we said maximum distance, right? And I believe we did this example, yes, okay. Where in this graph, we were told to calculate the maximum distance that PM could be, the maximum length of PM, okay? So even though we learn it as a vertical distance and we learn it as a distance between two graphs, they don't specifically mention, okay, calculate the distance between the two graphs. They just want the maximum length of PM, and you have to identify that PM is actually the distance between two graphs, okay? It's the distance between g of x, which is on top, and f of x, which is at the bottom at this point, P and M. So we said the top graph, which is g of x, minus the bottom graph, which is f of x. Okay, and we subtracted the actual equations and we formulated a new equation. Okay, it was a quadratic equation, and this equation represents the vertical distance between the two functions when g of x is greater than f of x. Okay, and then how do you get, so once you say top graph minus bottom graph, okay, how do you get the maximum? Since we are dealing with a parabola, remember, maximum or minimum is calculated by turning point. Y turning point is actually the maximum or minimum value. So once we get our new equation, we can calculate xTP first, of course, and then yTP. So xTP is negative b over 2a, and then yTP, you sub xTP into the original equation, and you get the value of YTP, and the value of YTP is basically your maximum, alternatively your minimum length. Okay, so I hope that makes sense. Let us continue. Okay, then we discussed roots and or x-intercepts in terms of parabola graphs. Okay, so we discussed them with the discriminant as well. The discriminant we said is this triangle, which is equal to b squared minus 4ac, right? The triangle is a symbol that represents the discriminant. Okay, then we said what happens when we started at the bottom, real unequal roots. So basically just real roots. Okay, when we have real roots, meaning we have two real roots, by the way. Okay, two real unequal roots intercept. So when we have two intercepts, your graph would look something like this, and your discriminant is actually greater than 0. B squared minus 4ac is greater than 0. And we said what happens if they have no real roots? That's when they don't touch the graph at all. In that case, b squared minus 4ac is less than 0. What happens when it's touching the x-axis? This is when b squared minus 4ac is equal to 0. Okay, we actually have the turning point on the x-intercept, and we say that we have two equal real roots. There are two roots, they just equal because they're both on the x-axis. Okay, then we talked about intersection of graphs. So steps for determining points of intersection, equate the two functions. So yes, when you have two functions, okay, which cross over each other at certain points, for example, here we have a and b. Okay, we have a and b. So in that case, a and b is what? Okay, a and b are two coordinates where f of x and g of x are touching. Okay, two different graphs where they intersect. So again, in your question, they're not going to tell you calculate the intersection point at A. They're going to tell you calculate the coordinates of A, and you need to go to A and understand what is A? What is special about A? Is A a turning point? Is it the vertical distance? No. Oh, okay, A is actually an intersection point. And then ask yourself, do I have enough information to take it from there? Okay, to then now equate the two equations, because that's how you would solve for an intersection of graphs, right? And obviously your marker location is a big guidance as well. Okay. So equate the two functions. So f of x is equal to g of x. Solve for x, look at the applicable x value, a or b, substitute the applicable x value into any of the two equations to find y. Okay, so we're going to do that. We're going to equate these two graphs. I'm actually just going to change this to negative, just so that it makes more sense. Okay, so we have g of x, which is our straight line function. We have f of x, which is our parabola function. And we want to find the intersection points, so we're going to equate them. So I'm going to say f of x is equal to g of x. Okay. F of x is x squared plus 3x minus 2. G of x is minus 2x plus 4. Okay, and now I need to simplify, so I need to try and get everything onto one side. X squared plus 3x plus 2x. Okay, I took this guy over as plus. Now I can take the 4 over as plus as well. And I get minus 2 and minus 4 is equal to 0. Okay, so now I'm left with x squared, okay, plus 5x minus 6. X squared plus 5x minus 6. Okay, so I thereafter factorize. Okay, because I need to find my x coordinates, right? Always, when you need to find your x coordinates from a trinomial, you're going to factorize. Okay, so I'm not sure if we've done trinomial factorization. I'm pretty sure we have at some point when we did equations and inequalities. Okay, so for those of you who still struggle with factorization, factorizing a trinomial, you can utilize your calculator, but factorizing a trinomial is always going to be better. Okay, just because Getting your brackets is a different story, but it's fine. So x squared, I'm going to use the factors of the first term. It's going to give me x and x. My signs, okay, depend on the second sign of trinomial. So if the second sign of trinomial is a negative, then I get a 1 plus 1 minus, and it doesn't matter in which bracket I put it in this case, because it's not going to change either way, either one I put it in. Then I have the factors of -6 or 6 to give me 5. So of course, when I add or subtract these factors, I need to get 5. So if I consider the factors of 6, 3, and 2, okay, yes, I could add these two and get 5. But as you can see, one bracket is plus, one bracket is minus, so I cannot use 3 and 2. So I have to use 6 and 1, and not 6 plus 1, because that gives me 7, 6 minus 1, that gives me 5. So I can have a positive 6 and a negative 1, that's going to give me positive 5. Okay, now I equate each bracket to 0. So x plus 6 is equal to 0, or x minus 1 is equal to 0. Take it over to the other side, x is equal to -6, or x is equal to 1. So since I have equated the two equations, right, and I got the new equation again that represents the intersection points, and I factorized it, these x coordinates, x1 and x2, are now basically my coordinates for A and B. So if we consider which one is more left, that would definitely be -6 is more towards the left. So therefore it takes the more negative value. Okay, and then this is 1. Now, how do we find their respective y values? Can anyone tell me? How would I find the y values of A and B now? Now that I found the x values, how would I find the y values? Now that I found the x values, how would I find the y values? %, very good, right? I substitute the x values into any of the formulas. So because remember, right, this coordinate A and B, okay, it's a coordinate for both graphs, okay, for f of x and g of x. So I can technically take my x values and sub it into g of x, or I can sub it into f of x. So I'm going to choose g of x just because it's easier. I don't have to deal with squared. Okay, so I'm going to say to calculate y1, I'm going to have -2 open brackets, -6 plus 4. I'm utilizing g of x. G of x is equal to -2x plus 4. Okay, so now I get y1 as being positive 12 plus 4 is 16, I believe. -6 is positive 12 plus 4 is 16. How do I get y2? I can substitute x2. I substituted x1 and I got the y1 coordinate. Now I can substitute x2 and I'm going to get the y2 coordinate. This we said is 16. So -2, 1 plus 4. y2 is equal to -2 plus 4 is positive 2. Yeah. So basically, I've solved for my equation, or for my intersection points. A is -6 and 16, while B is 1 and 2 as their point of intersection. Okay, so there we go, points of intersection. Maybe the tricky part about this is, once you have the calculation down, it's just understanding that the question wants you to utilize points of intersection of the graph to calculate a certain coordinate. All right, that's, I feel like where a lot of people confuse it. Okay, let's talk about increasing, decreasing, which we've technically spoken about already, but it's going to help us in this section as well. So we always consider from left to right. Okay, remember the technical term is we look from left to right and we ask ourselves the question, are the y values increasing? So if we move from left to right, always, which we always do, always move from left to right. If we move from left to right and the y values are increasing, that's when we have an increasing function. If we move from left to right and the y values are decreasing, that's when we have a decreasing function. Alternatively, you could rely on good old Bob. So if Bob is here on the top, moving from left to right, okay, is he going to be sliding down or is he going to be climbing up? That's a question you can ask yourself. Or is he going to be going down or going up? Doesn't really matter. If he is going down, that part of the graph is a decreasing part of the graph. Then it changes here at the turning point, as it always does. And now we consider Bob moving from left to right. Is he going to have to move up or is he going to have to move down? He's clearly going to have to move up, and that results in an increasing function. Okay. And here we can see moving from left to right. Initially, it's increasing, but towards the end, it is decreasing. It changes at the turning point. So it changes from increasing to decreasing at the turning point. Okay, always moving from left to right. Let's have a look at this. Determine the values for which f of x is increasing at turning point. Okay. So now we are discussing increasing parts of the graph in terms of x values. Okay. So now it's like a proper question where you need to give an answer. Okay. So for which x values is f of x increasing? So your first job is to identify which is the part of the graph that's increasing. So f of x is the parabola, by the way. Okay. We have to figure out which part of this graph is increasing, and we can see that it's from where it starts to somewhere around the turning point. Okay. To somewhere around the turning point. So now visually, we have identified, okay, where this graph is increasing, right? That's number one. Number two is to note, as it said on the left, at the turning point, the graph is not increasing nor decreasing. So at the turning point, okay, here, the graph is not increasing or decreasing. Actually, it has a slope of 0. You're probably not going to utilize this information, but it's interesting to note. Okay, when we draw a tangent line at that point, right, it's a horizontal line and its gradient is actually 0. Okay, you'll see later on when we do calculus, in order to get turning point, we actually we derive it, which you guys haven't learned, but you derive it and you equate it to 0 for that specific reason. Okay, because the gradient there is 0. So if you remember, we said if the gradient is 0, right, it's a flat surface. So we can't really describe a flat surface as increasing or decreasing. Okay, so please remember, at the turning point, the graph is neither increasing nor decreasing. Okay, so now we need to express this highlighted part of the graph, because we can all tell, okay, that's the increasing part of the graph. But now, can we turn that into an answer of x values? Can we turn that into an interval? Okay, so first things first, we have to obtain the coordinate, at least the x coordinate of the turning point. Okay, so I'm not sure those of you picked that up, but because it is part of our interval, so we start at -infinity for this increasing, and then we end at the turning point for increasing. So in order to express the answer, we need to get this x turning point. And if you remember correctly, we don't have to do negative b over 2a in this specific case. We don't have the equation, firstly. And secondly, you can utilize the midpoint method, where you calculate the midpoint of the x-intercepts, okay? And the midpoint of the x-intercepts actually gives you the x turning point, if you remember that from when we learned parabola. So midpoint of -2 and 5, you can simply say -2 plus 5 over 2. That becomes 3 over 2. Okay, so the x coordinate of the turning point is 3 over 2. So now we can give our answer, because, okay, remember our method. What's our method? We're going to answer in terms of x values. Cool. So we're going to say x is an element of. Remember, we learned this. Okay. So, round brackets means exclude. Square bracket means include. We never include infinity, positive or negative infinity, and asymptotes. We never include asymptotes. Okay. So in this case, now, remember, when we are answering in terms of x values, okay, when we are answering in terms of x values, I believe the first place we did it was when we discussed the domain and range of parabola. Now, these apply all over. These are for y values in general. So whenever you're expressing x values in that interval notation, okay, you can expect to have that x is an element of your starting x value as your first digit and your ending x value. So when we talk about x, your starting value is your most left value and your ending value is your most right value. Okay. When we talk about y, your starting value is your lowest value. Okay. And your ending value is your highest value. Okay. So let's apply that same logic to this specific scenario. So what is the most left digit? Because remember, x is an element of your start value and your end value. When we talk about x, we say our start value is our most left value and our end value is the most right value. So in this graph, can someone tell me what is the most left value? What is the most left value? Of the highlighted region, that is, of the part of the graph that's increasing. Okay, so if we have to consider this graph, okay, the most left value, so here's the highlighted portion. The most left value is somewhere here, because remember, this graph continues on forever and ever and ever. So it continues forever left. Okay, it's going to go forever, more left, more left, more left, more left. So in that case, the most left value of this graph would then be negative infinity. Okay, not positive, because we are heading in the negative direction. And since it's going to continue like that forever, its most left value is negative infinity. So I have to exclude, I have to use a circle bracket because it's infinity. Okay, so we never include with infinity. So negative infinity is my start value, my most left value. Okay, yes, do not confuse it for -2. I was waiting for that. So the reason we confuse it for -2 is because -2 is the most left value that we actually know on this graph. The most left value that's actually plotted on this graph. Negative infinity is not plotted. Neither is perhaps -5 or -500. Okay, none of those are plotted. However, because we can see that this graph is going forever left, we can see that it is going till negative infinity. Okay, so please note that. Do not make that mistake. Okay, this graph, its most left value is not -2. Maybe the most left value that's plotted is -2, but actually, right, if this graph goes on forever and ever, its most left value is negative infinity. Okay, now again, we're talking about the highlighted region of the graph. Okay, now let us talk about the most right value, because that's our end value. What is the most right value? X value, of course, because we're answering in terms of x values. What is the most right value of the highlighted portion? Okay, so just give me 1 minute while you guys think of this. Please leave your answers. I'll be back in Okay. Okay, Zoom is just not responding. Let's just wait. Okay, I'm not sure. Can you guys hear me? The video is not working. Taking a while to load. Can you guys hear me though? Okay, that's fine. So sorry, my Zoom is not working. Thanks for replying on YouTube. As long as you can hear me and my screen is moving, that's okay. I don't know, my Zoom is not responding on my laptop, and the camera is also not responding, but it's fine. It should work again shortly. But nevertheless, as long as you guys can see the screen and hear me, let's continue, right? For now, I can't see the Zoom chat, but it should load up shortly as well. Okay, so yes, we have the answer of 3/2, and that is correct. Okay, so the most right part of this graph, of this highlighted part of the graph, is 3/2. So that's going to be in our answer. Okay, because on the right hand side of our interval, we're going to have the most right value, and that's going to be 3/2. Now, someone tell me, do I include or do I exclude 3/2? Remember, we are discussing, is this graph increasing, or which parts of this graph is it increasing? So do I include or do I exclude 3/2? I can't see the Zoom chat. So pity. Let me see if I can load it up. Technical issues. Okay, I should be able to see the chat now if you guys type, but yeah. Okay, so my question was, do we include or exclude? So actually, for this turning point question, we have to exclude. When it comes to increasing or decreasing at the turning point, we have to exclude. at the turning point specifically, because remember, because of the statement, it says that at the turning point, the graph is not increasing nor decreasing. So we cannot include it in a statement that says that describes where the graph is increasing, because that's what this interval does, right? This interval tells us that when x is an element of negative infinity to 3/2, the graph is increasing. Okay. And yes, we cannot include 3/2 again because it's a turning point, and at turning point, it is neither increasing nor decreasing. Okay. So yes, let's do this example. Determine the x values again for which f of x is decreasing. Okay, so now we want to determine the values for which f of x is decreasing, right? Remember, we calculated this as 3/2. Okay, so now I'm going to identify the part of the graph that's increasing. Again, it's f of x. So I can look for the part that's from left to right going downwards, and that would be this part. So this is the part of the graph that's decreasing. Now, someone please tell me what. So we have to answer this. How do we have to answer this? We have to answer this in terms of x values. We have to say x is an element of. Now we're dealing with x values. So the most left value and the most right value. Most left value and the most right value. So what is the most left value of the highlighted part of this graph? What is the most left value of the highlighted part of this graph? Three over two, correct. Okay, 3/2 is correct. The most left part is 3/2. What about the most right part? So I'm going to say x is an element of. I don't include, I'll mention exactly why in a bit. What's the most right value? So of the highlighted part of the graph, what's the most right value? Positive infinity, exactly, brilliant, right? So this graph is going to go on in terms of x values. So we consider, what are x values? X values are here on the x-axis. So the most right value continues to go right and right and right. So you might look at this and think it's going down. But while it's going down, it's also going right. It's going down and right continuously. So therefore, it's going forever to the right as well as forever down. Okay, but since we're talking about x values, it's going forever right. And that's why we discussed positive infinity. So the most right value is actually Okay, it looks like I'm guessing that you guys can hear me now. It looks like I'm gonna just have to use this audio. Please confirm that you guys can hear me, and then we can continue. Okay, it's fine now, and then you guys can still hear me. That should be all fine. Okay, the camera is glitching out Zoom, so I'm not going to switch it on for now. But let's try and finish up, right? So I'm really sorry for the delay, but let's continue nevertheless. Okay, so determine for which values, right, x is greater than 0. So again, if we determine for which x values x is greater than 0, that's of course is going to be x greater than 0, because that's how we represent it in terms of x values. But to really understand what they mean, we can say that, what does it mean for x to be greater than 0? We can understand it as it being to the right of the y-axis, okay? And let's answer that firstly in interval notation, okay? So we can say everything to the right of the y-axis, x is an element of, okay? Now, if I had to identify, which is the key part of this, if I had to identify which part of this graph, okay, is to the right of the y-axis, sorry if I'm saying left of the y-axis, I mean right of the y-axis. If I have to identify the part of the graph that's to the right of the y-axis, I would have to highlight this part. Okay, I'd have to highlight this part here. Now, tell me, what is the most left x value of this highlighted region? What is the most left value of this highlighted region? Incorrect. You see, not -3. This is where we need to avoid that confusion. -3 is a y value. Okay, -3 is a y value. You see, when you are asked interval notations, you are always asked to answer in terms of x values. Okay, never in terms of y values. So you need to always remember x values. And in that case, right, where y is -3, x is actually 0. So the most left x value in this case is 0. And I'm actually going to exclude, not for any of the reasons we learned before, but I exclude here because the question actually excludes in their interval. They say they just want the values for that are greater than 0, values for x that are greater than 0. So above 0, right? We're not talking about 0. We're not including 0. Okay. So in that case, we will exclude 0 as well. What is the most right value? When we talk about the highlighted part, the most right x value. That's why we talk about most right, because it's an x value. What is the most right x value? Positive infinity. Brilliant. Makes excellent. Makes sense. So it goes up until positive infinity. And of course, we never include infinity. So that's how we could represent x being greater than 0 to the right of the y-axis. If we want to express this into as an inequality, we just, again, x is greater than 0, of course. This is the same thing as that. Okay, let's talk about x being less than or equal to 0. So x being less than or equal to 0, I need to identify the part of the graph that is to the left of the y-axis And that part of the graph is this part here. That's the part of the graph that is to the left of the y-axis. Now, when we consider this highlighted region, what is the most left value of this part? So I'm going to say x is an element of. What is the most left value of this highlighted part? Negative infinity, very good. I never include infinity, so it's a circle bracket. Now, what's the most right part of this graph? Zero, great. Okay, because it's not -3, -3 is a y value. What's the most right x value is essentially what I'm asking, and that would be 0. Okay, so now, one more thing is, do I include or do I exclude? In this case, I will actually include 0 because the question includes. So when the question includes, actually, you'd use only square brackets, right? For everything, except with the exceptions, which is like negative infinity. You can't include infinity. Even if the question includes, you won't include infinity because what are you including, right? Infinity is goes on forever. So it's not, you can't include one specific value, okay? That's all fine. Let's move on to the next one, right? Now let's talk about determine the x values for which f of x is greater than 0. Now, f of x being greater than 0 means y greater than 0 because y is f of x. Y greater than 0 means simply above the x-axis. Y being greater than 0 or f of x being greater than 0 means above the x-axis. Okay, so let us identify the parts of the graph that are above the x-axis. Okay, the parts of the graph that are above the x-axis would be this part and that part, right? That's easy to visualize, easy to see and agree with, like, okay, yes, that's above, and then below is the rest of it that's below. So above the x-axis is the highlighted parts. So since we have two highlighted parts, like split, right, two different highlighted parts, we're going to have two answers basically. Okay, now this first region of the graph that's highlighted, okay, is above the x-axis, which is this part here. Now, again, we're considering the most left value and the most right value. So someone tell me, we are missing a value, I think -2. So someone tell me now, okay, for this yellow highlighted region, so you can even, if you'd like, put dotted lines for your start and your end. The end for that is, okay, you put dotted lines for your start and your end, and then just give the x values between those two dotted lines. Okay, so now tell me, what is the most left value here? For this yellow highlighted region, what is the most left x value? Just for the left part. 100% correct, right? You guys are awake today. Okay, 100%. The most left part is negative infinity. So for this reason, I'm going to say x is an element of, I never include infinity. So I have a round bracket, negative infinity. What's the most right value of this highlighted part of the graph? What is the most right value of the highlighted part of the graph? -2, excellent, right? You guys are getting it. -2. Again, it's not 0 in this case because we're dealing with x value. So if we have an x value here, we have the x value as -2. So it's -2. So I've expressed one of my answers. X is an element of negative infinity and -2. Okay, I know time is up, but we're going to continue a little bit extra just to try and catch up. Then I consider this the other section of the graph that's above the x-axis. So remember, both of these parts of the graph satisfy the criteria. What is the criteria? They want f of x to be greater than 0. So both of those parts of the graph satisfy that criteria. So we have to identify both of them. Okay, and then express it in terms of x values. Okay, so now this part of the graph. So tell me what is the most left part of this graph? So I'm going to have to say x is an element of. What's the most left part of this highlighted region? That specific highlighted region. One, perfect. So the reason I'm excluding 1, and it's the same reason I've excluded 2 there, is because the question excludes. So when the question excludes, you will exclude as well. Okay, and obviously like infinity is always excluded. Okay, and what else? Asymptotes are always excluded. Okay, even if the question includes. What's the most right value of this highlighted part of the graph? X value. What's the most right X value of the highlighted part of the graph? That's a mouthful. Positive infinity, very good. And I never include infinity, so that's my answer. Okay, let's try and quickly do this one. So here they want the values of f of x, okay, that are less than 0. So when f of x is less than 0, that means y needs to be less than 0 because f of x is y, or this is less than or equal to. What does y being less than or equal to 0 actually mean? It basically means that when you are below the x-axis, when you are below the x-axis, when you are below the x-axis, that's when y is less than 0. So now I can identify, and again, which is generally the easier part, you just visually identify and highlight. You can highlight. It's legal to use a highlighter in the examination, believe it or not. Okay, you can use a highlighter and highlight the part of the graph that's actually now below the x-axis. So that's simple because I just look at my x-axis relative to my x-axis. I'm going to highlight the part of the graph that's below it, and it's the yellow region. Okay, now tell me again, we follow the same process. X is an element of the most left value and the most right value. Okay, when we consider, again, like I said, if you'd like, if it helps you to visualize it, you can draw a little dotted line on the most left part of your graph and a vertical dotted line on the most right part of the graph. So you can see it in terms of X values, kind of. Right, sorry, those are a bit skew, but yeah, nevertheless. So now tell me, what is the most left X value of this graph? What is the most left X value of this graph? -2, correct. So my answer is actually going to be, for now, X is an element of, okay, so you guys are correct. The most left X value is -2 of this highlighted region, right? You can read that from the graph. Do I include 2 or do I exclude 2? That's what I want to know now. Do I include 2 or do I exclude 2? Okay, so the first question you got to ask yourself is it an asymptote? No. Is it infinity? No. So when it's not an asymptote or it's not infinity, then it depends on the question. If the sorry. Both of these should have an include so that it's uniform. Okay, so like I said, if it's not an asymptote or if it's not infinity, then it depends on the question. If the question includes, you include. If the question excludes, you exclude. In this case, the question includes, so I will include with my whole square brackets, and I will indicate my most left value, which is -2. Now, what is my most right value of this highlighted region of the graph? One. Very good. 1. Okay. And since it's 1, yeah, we include as well because the question includes, because 1 is not an asymptote. Remember, my dotted line is not an asymptote line. My dotted line is just to show that that's the end of that highlighted region. Include again because the question includes, And yeah, that's basically it. Okay, so we've done the 4 simple ones, like simpler, okay, where we talk about X values being on the right of the Y-axis, on the left of the Y-axis, Y values being above the X-axis, Y values being below the X-axis. And next we are going to talk about dealing with F of X and G of X together, dealing with 2 graphs together when they give you criteria for 2 graphs and questions like this. Okay, where you have to multiply them. Most of us just look at it and we ignore it and we move on to the next question. We're actually going to explore how can we answer those questions and how can we not skip them. Okay, so yeah, so unfortunately I would have loved to finish more, but time does not permit and we ran into a whole bunch of technical issues today, but it's okay nevertheless. Yes, correct, include. Okay, it's okay nevertheless. We are going to continue. I know that maybe most of you are on holiday currently, some of you are fasting, it's going through the most. But yeah, functions is taking long, but hopefully we're going to finish up next week. And yeah, finish this up and then do a question and then move on to trigonometry and try and be prepped for term 2. Do you guys know when do you start? Like what date do you guys start term 2? I do know actually, more or less. If I can check this. You guys should be starting on the 12th, I think, 11th or 12th. Yeah, okay. Okay, that's actually perfect. That's great. We have enough time to catch up, maybe do some revision, maybe do some extra questions, and actually no, just finish trigonometry and move on. Yeah, exactly. So we're going to try to not skip this part. So I just wanted to say, I know that some of you have messaged me to ask questions. It's been a really chaotic week. I apologize. I did not have time to reply. And I'm really not sure if I'll have time to reply this week either, just because I myself am writing examinations. So it's a bit chaotic. Okay. So yeah, those of you who are joining. So I'm really sorry about that. But like I said, it's been extremely hectic. Those of you are joining the extra class now, sorry, it is a bit late, so I'm going to allow a 5-minute break and then we will start again. And then, yeah, we will start again to continue with the extra class. But yeah, for now, I'm going to end this one and I'll send out the link for the extra class. 10th or 12th April, 3rd of April. Your term 2 starts 3rd of April. That's really early, man. But yeah, okay, cool, guys. Thank you guys so much for joining on this lovely Saturday morning, where a lot of people that are supposed to be are sleeping. So well done to you guys. Okay, all the best. Have a good week of either school or holiday, depending on what you're on. And yeah, hopefully your guys' report card is looking good. But for now, that's it for me. I will see you guys same time next week. Thank you guys.